Lesson 8-6. Solve quadratic equations by factoring. Objective: I can solve quadratic equations. Essential question: how do I determine which method is the most efficient way to solve a quadratic by hand? Example 1. Zero product property. So let's go over the zero product property. So if we have numbers, factors multiply together, it equals 0. That means that one or more of those factors must equal 0. So for example, if we have x times x plus 2 equals 0, we either have the first factor x equals 0, or we have the second factor x plus 2 equals 0. So our solutions could be x equals 0 or x equals -2. So let's look at this one. X minus 2 times x plus 4 equals 0. So from the zero product property rule, we know that x minus 2 equals 0 or x plus 4 equals 0. So we're going to solve for x for each of these separately to find our two solutions, our two roots. So to get rid of this minus 2, we're going to put a plus 2 on each expression. -2 plus 2 is 0. So if x equals 0 plus 2 is 2. So if x equals 2, or let's solve the other equation. X plus 4 equals 0. Subtract 4, each expression. So we have x equals -4. So our two zeros are x equals 2 and x equals -4. So the first step for these, you separate the factors and set them equal to 0 separately. And the other step, the next step, we solve for x. Example 2. Factor when a equals 1. So if x squared minus 5x equals 14. So the first step you want to do is to rewrite it and give yourself some space on the left side of the equation so you can move that 14 over. Step 2, let's subtract the 14 from each expression. And then break down everything. So if x squared minus 5x minus 14 equals 0. Notice I put that plus 0 in the space so we can line up the constants together. Okay, the next step, we want to identify a, b, and c. A is the coefficient of x squared, b is the coefficient of x, and c is the coefficient of the constant. There's one x squared, so a is 1. If there's nothing in front of the variable, there's assumed to be one of them. B is -5, not -5x, just -5. And c is our constant, -14. So we need everything on one side of the equation with 0 on the other side so we can identify a, b, and c correctly. Have the correct signs, positive or negative. Step 3, you're going to write your x. You're going to draw an x. So at the top of the x, you're going to have a times c. At the bottom of the x, you're going to have b. So a times c is 1 times -14. That's -14. B is -5. Now the next step, you're going to find two factors that multiply to -14 and those two numbers add to -5. And to do that, we're going to draw a table. So step 5, we're going to draw this table and list the factor pairs of -14. So we have 1 and -14, 2 and 7, and then of course we also have 14 and -1, and 7 and -2. So we're going to combine these numbers to see which one gives us -5. So -14 plus 1 is -13. That's not -5. Let's go to the next one. -7 plus 2, that's -5. Looks like that works, but let's keep going. 14 minus 1 is 13, and 7 minus 2 is 5. So it looks like -7 and 2 are your factors that you're looking for. So we have -7 and +2. So from here, we're going to write our two factors. We have x minus 7 and x plus 2 equals 0. So the last step, you're going to solve for x for each factor set equal to 0. Just like in the previous example, we used the zero product property. So we're going to separate the x minus 7 equals 0 and the x plus 2 equals 0 and solve them separately. So we're going to add 7 to each side, each expression. So we have x equals 7. X equals 7. And then we're going to do the other equation. Or subtract 2 each expression. X equals -2. So your two zeros are x equals 7 and x equals -2. So those are our two solutions. Those are our roots, our zeros. Example 3. Factor when a does not equal 1. 6x squared minus 13x equals 5. So this one will be a lot like example 2. So our first step is space. 6x squared minus 13x plus 0 equals 5. Okay, step 2, we want to move the 5 to the other side, so we subtract 5 from each expression. So we have 6x squared minus 13x minus 5 equals 0. Okay, the third step, we want to identify A, B, and C. So A is the coefficient of x squared, that's 6. B is the coefficient of x, the x term, that's -13. And C is the constant term, that's -5. The next thing, step 4, draw an x. So just like last time, we're going to draw an x and write AC at the top and B at the bottom. Find two numbers that multiply to AC and the same two numbers add to give you B. So A times C is 6 times -5. That's negative 30. And B is negative 13. So we're going to find two numbers that multiply to give you negative 30, and they add to give you negative 13. So we're going to draw a table to find the factor pair whose product is negative 30 and whose sum is negative 13. So we're going to write all the factor pairs of negative 30. And it needs to be a sum of negative 13. So our AC product is negative 30. So our factors would be 1 and 30, negative 1, positive 30, 2, negative 2 and 15, negative 3 and 10, negative 4 doesn't work because it doesn't go into 30 evenly, so let's skip to 5. Negative 5, 6. And then we're going to do the opposite, so negative 30 and positive 1. And if you're able to find the sum without having to write every single factor pair, that's fine too. I'm just showing you every single combination. So we have 29, that doesn't work, 13, 7, 1, negative 29, negative 13, oh, it looks like we found it, negative 7, and negative 1. So it looks like in this case, negative 15 and 2 are our factors. So we're going to write those in our X. So the next step, we're going to write our two factors. Okay, so we write our factors. We have parentheses X minus 15 and parentheses X plus 2 equals 0. But wait, since A does not equal 1, we have to divide these numbers by A. Now if we were to find the proper factors, we would slide them over. But we're just solving for the zeros in this case, so we don't have to do that. So from here we're going to use the zero product property to solve for X for each of these two factors. So let's rewrite these and simplify the fractions. So we have X minus 15 divided by 3 is 5, and 6 divided by 3 is 2. So X minus 5 halves equals 0, or X plus 1/3 equals 0. We divide each of these, the numerator and denominator, by 2 to reduce this fraction. So now let's use the zero product property to solve for X for each factor. So add 5 halves to each expression. So we have X equals 5 halves. And then the other equation, we're going to subtract 1/3 from each side, each expression. So we have X equals negative 1/3. So these are our two solutions. X equals negative 1/3 and 5 halves. Example 4, factor the greatest common factor. So first you want to find the GCF of the two numbers of 2 and 36. The greatest common factor of 2 and 36 is 2. So we're going to factor out the 2. And we always want to factor out the leading term's sign. And the lead term sign is positive, so we're just dividing by 2. We're factoring on a 2 here. So 2x squared divided by 2 is 1x squared. Negative 36x divided by 2 is negative 18x. Now the next step, you want to factor out the greatest common factor of the variables. And the greatest common factor of x squared and x is just x. You take the variable with the smaller exponent. So now we're going to divide out x. So x squared divided by x is x, because 2 minus 1 is 1. X divided by x is 1, because a number divided by itself is just 1. So we have minus 18. So this is the GCF is 2x. This goes on the outside. And then the leftovers, x minus 18, goes on the inside. Okay, the next step, we will rewrite it in our factored form. So we have 2x, our GCF on the outside, parentheses, x minus 18, our leftovers on the inside, equals 0. So now we're going to use the zero product property to solve for x of each factor. So we have 2x equals 0, or x minus 18 equals 0. So for 2x equals 0, we're going to divide each term by 2. 0 divided by 2 is 0. 2x divided by 2 is x. So we have x equals 0, or add 18 to each expression. X equals 18. So our two zeros is x equals 0 and x equals 18. Okay, let's look at the last example. Example 5. Factor using difference of squares formula. So we have 9x squared minus 4 equals 0. Here's our difference of squares formula. A squared minus b squared equals, parentheses, a plus b times a minus b. Notice that these a's and b's are not the same thing as what we've been doing on the previous examples. This is like the entire base. So this one's base is 9x and this one's base is 4. So let's go ahead and find those. So we're going to identify a squared and b squared. That's what we want to do first. After you identify a squared and b squared, which is 9x squared and 4, we want to find a and b. To get rid of the square, we're going to take the square root of each side, each expression. The square root of a squared is a. The square root of 9 is 3. The square root of x squared is x. So a equals 3x. And then let's find b. Square root both sides. B equals 2. And we'll put plus or minus 2. Whenever you find a number and you square root it, you can have a positive or negative answer, because 2 times 2 is 4, and negative 2 times negative 2 is also 4. The next step is to plug it into the formula. So we have 3x plus 2 times 3x minus 2 equals 0. From here, we want to use the zero product property to solve for x of each factor. So we have 3x plus 2 equals 0, or 3x minus 2 equals 0. So for the first equation, we have 3x plus 2 equals 0. So to solve for x, we will first subtract 2 from each expression. So then we have 3x equals negative 2. Divide each term by 3 to get the x by itself. 3x divided by 3 is 1x. Negative 2 divided by 3 is just negative 2/3. So if x equals negative 2/3, that's one of our zeros. And let's find the other one. 3x minus 2 equals 0. Add 2 to each expression. So then we have 3x equals 2. And then divide each term by 3. 3x divided by 3 is 1x. 2 divided by 3 is 2/3. So we have x equals 2/3. So our solutions are x equals negative 2/3 and positive 2/3. We have a difference of squares. You'll always have a positive and a negative that are the same, plus or minus 2/3. So it could also be written like this: x equals plus or minus 2/3.